Hello everyone, welcome to my YouTube channel. So this is episode number 14 on the deep learning with Pytorch series. So far we are still doing the groundwork and we will slowly move into the neural network implementation after this video. So this is the last thing which we need to know before building a neural network using Pytorch. So the last thing is PyTorch dataset and data loaders. So we ideally would want our dataset preparation step, which is in general a very complex process, to be decoupled from our model training code or process, right? So this is for better readability and also for the modularity perspective. So PyTorch has this two data primitives, which can help us to separate out our data preparation task from the model preparation task, right? So these two data primitives are like torch.utils.data.dataloader and the dataset, right? So what is this dataset and data loader, right? So dataset stores samples and their corresponding labels. So if we have like our dataset, which is like a training dataset where we have the X and Y, right? X is your feature and Y is your label. So your dataset will be kind of a wrapper, which will kind of wrap these two things together and then it will give you an output, right? In some of the cases, you may not have the labels. So label is kind of optional for your data set, and you can simply create a wrapper on top of your features, right? And this data loader is kind of a wrapper, which creates iterable objects around the data set, right? Which we can easily loop through and access each of the samples, right? And also like data loader helps us to create batches of training data through which we can do the gradient descent optimization, right? So let's start with at first what is data loader. So first of all, we will import torch. Then using this torch.utils.data, we will import this three primitives like data loader, dataset, and tensor dataset. And at first, for to demonstrate what a data loader is, I will create a variable, a torch tensor, which like starts from 0. It will have the value still 11, right? So this is how it looks like. Then I will kind of create an iterator using a data loader, right? So if I just call data loader and pass this X as a parameter to this, and it will create a data loader, and then we can loop through each of the items of my data loader, right? So this is how it will look like. So I'm just printing each of the elements while looping through the data. So this is where you are accessing each of the elements, right? So it's like it. This is the way when we do stochastic gradient descent, right? We are updating the model parameters for each training examples. Now, if you want to do a mini batch gradient descent or a mini batch gradient descent, right? So that time we need to have a component which is where we need to mention the batch size. So we will create batches of data, right? So data loader kind of enables you to do that. Here you will mention the batch size equals to 4, and based on that, it will create a data loader out of it, which will so as we have like 12 training examples, 12 data set here, and we are creating a batch size of 4. So we will have 3 batches, and each batch will have 4 records in them, right? And sorry about that. And we are mentioning shuffle is equals to true because we are kind of reshuffling the data. So it might happen that in your training data set, there is a data order which creates a bias while you are training your neural network, right? So you want to remove that bias from the data, or that order bias which can be present in the training data set, that you want to remove, and which may not be available in the test data set, right? So that's why you want to shuffle your data set and create the batches of data. So this is the way to do it. Then we can have our both features and target, right? So we have our X's and we also have our Y's, right? So let's create X and Y using this scikit-learn dot datasets and make classification. Using this, I will create 10x features or 10 samples of features and 10 sample of my target variable. So the features will have 20 the 20 as dimension. So you can see like there are 10 rows and 20 features for X, and there are the Y shape is 10, right? Which is kind of a one-dimensional target. So if once I have that, so to create a data loader out of it, at first we need to wrap these two things, right? So it is quite similar to the zip function which we have in Python, right? So we kind of generally incorporate two things using a zip function, and we try to merge the corresponding element wise values from two separate lists using zip. Here we are kind of combining X and Y. Before that, we are converting those to a torch tensor, and then we are creating a data set. Once the data set is created, we are using this data loader function. We are mentioning batch size equals to 4, and then we can loop through our data data, right? Let me run this at first. Yeah. So you can see like batch one is this, where we have like these are my features which are like X variable, and we also have corresponding Y, right? So I created 10 samples, right? So 10 is the total sample size of my X, and I am creating a batch size of 5. So two batches will be created. This is the first batch and this is the second batch, and each of them will have 5 records. And for 5 records, there for each records there will be 20 features, right? So this is how it looks like. So this is how we can, using tensor dataset, we can wrap X and Y and then create a data loader out of it. Now, in some of the cases, you want to create your own custom dataset class that will kind of inherit from the Pytorch dataset class. And if you don't know the concept of OOPS, so I will link one of the description, one of the videos of my from my previous playlist, and from there you can learn the concept of OOPS, right? And so here we are creating a class. And generally, we do this when we create a very complex process and we don't want to load our full data set into the memory. So we want to, like, we are doing complex operations on each of the X's and Y's, and we don't want the full data set into our memory, which can crash your system, and that will not be efficient process. So what we generally do is we create a custom class, which is like custom data set. There we have, at first, we need to implement three methods: init, len, and get item, right? So the init is nothing but the initialization, where we are converting our X and Y to torch tensor. Then len will return back the shape of my X, right? And in the get item, we need to visualize in your mind such a way that your get item will return one training example or one vector of a combination of my X and Y, or features or target, right? So using this IDX, we can implement that. So we will use this self.x, then IDX, to access each of the elements from my features and target. And then in the end, we will return this in pairs, my features and target. So once this custom dataset class is implemented, we will create an object out of it, and we will pass my X and Y. And then using this data set, we can pass, using this data loader, we will pass my data set, and we will mention shuffle equals to true, and also batch size equals to 5, right? Then it will kind of create batches of data in the similar way, but with the help of custom data set, right? And also in some of the cases, you may want to do like read the data from dataset, or you want to read from your disk. So, and also you want to do some data augmentation task, right? Or image augmentation task, which we will discuss in far more detail when we will go through the CNN, right? So those operations, in those cases, we don't want to bring all the records or full data set into our memory, right? We want to do it in batches. So this custom data set will enable us to do that, right? And those reading operations or fetching operations or the augmentation operations you can define here, then you can like use that in the later section in this get item method, right? So I hope this is useful to you. So with this concept, in the next video, we will try to implement a neural network on the MNIST data set. So that will just get you started how to build a basic simple neural network with pure PyTorch, right? So thank you for your time. I hope you like this video, and also if you like this whole series of videos on the PyTorch with deep learning with Pytorch series. Please share with your friends and colleagues. Thank you all. Thanks for your time.